In this lesson, we are looking at functions and their properties. And here we are going to start by reviewing the vocabulary associated with a function. So remember, a function is a rule that assigns every element in the domain to a unique element in the range. So make sure you get a unique element in the domain to a unique element in the range. And remember the notation, we write y is equals to f of x, and the domain are the dependent variables, for example x. Range are the dependent variables like y. So here we have some examples here. So let's talk about some functions and non-functions. So examples and non-examples. And here I want you to see all these equations. And here what we are saying is you cannot write an equation in terms of y or f of x if it is not a function. So if you see an equation like this, it's a function. So here, let's look at this one. Here we have a table, and I want you to focus on the domain, the x values, and you can see that each x value has a unique element in the domain. So you look at the x values, look at the output or the y values. They are unique for every x value. When I look at the non-examples, what makes them different? If you look at 0, the output is 9. So you plug in 0, you get 9. You plug in 2, you get 9. So that's not possible. So that makes that not a function. So here, you plug in 0, you get 5. You plug in 1, you get 5. You plug in different numbers into an equation and you get the same value. That's not possible. So that means these are not functions. And here, we review here the vertical line test. And this is a line that intersects the graph and intersects the graph. And you know, and this is how you check if any vertical line intersects the graph at more than one point, it's not a function. So we look at this one. If I make a vertical line at every point, it's going only to intersect it once. So that means they are functions. Same as this one. They are functions. But these ones, if I make a line, it cuts the graph twice. See, like this one cuts the graph twice. See, this line cuts the graph 4 points twice. See, these ones. So these are not functions. Okay, now here, let's look at one-to-one function. What does it mean by one-to-one function? So just a quick review of what we did here. So here we have, see, you can see this is not a function. Why? Because 2 produces 2 outputs. And see, this is a function. See, this is one-to-one because every x value corresponds with only one element in the output on the range. So that is one-to-one mapping. So let's look at how to find the domain of a function. When you're looking for the domain of a function, so these are the things we need to remember. You cannot divide by a 0. You cannot take the square root of a negative number. So there are 2 methods we are going to use. We're going to use algebra, and we're also going to do it graphically. So method 1, graphically. So here I have this equation, the x squared. I have x squared plus 6x plus 9. See, that's the equation I have. And see this equation right here. And I can see this is a quadratic function. And another easy way of looking at this is can I be able to substitute any x value into this equation? Or is there any value of x which is not acceptable? And I know the answer is no. So that means the domain are all x values. And the way I'm going to write the domain, I'm going to use the interval notation. So it's going to be from negative infinity to positive infinity. And you can see the other method is just graph it on the calculator and look at the domain. See, this graph continues indefinitely. So it means all x values are part of this equation. If you make, and also you can check, if I draw a line from the graph, it's going to touch the x-axis. If I make a line, it's going to touch the x-axis at one point. So that means the domain is all real numbers. So, and that's the answer. And I can also do the range. So what is the range? So the range, you can see, range we are focused on the y values. So it's starting over here, going up. If I draw a line on the y-axis from -2, it's going to touch the graph somewhere. So the range is going to start from -2, and -2 is included, so I use a square bracket. I use a bracket to positive infinity. When you are writing the range, you always start from the bottom up, and when you are writing the domain, you start from the left to the right. So those are the answers for the domain and the range. Now let's look at another example here. So we are told to find the domain of y is equals to square root of x minus 3. So how do we do this one? This is what we need to know, that the number under the radical x minus 3 cannot be a negative number. So it means everything in there could be 0, because the square root of 0 is 0, but it cannot be negative. So 0 or more. So if I solve this equation, so I'm going to add 3 on both sides. So I get x is equal to or minus 3. So what does that mean? The only acceptable numbers are values which are greater than 3. So how do I write this using the notation form? So the domain is going to be from 3 to infinity. Okay, that's to infinity. So that's open, and this is bracket. And as I'm here, I could also write the range. And I can look at the graph here. Look at the graph. Look at the graph. The values start at 0 to infinity. Zero is included. And I want you to check graphically. You just look at the graph. The values of x start from here. So from here, going in this direction to infinity, because the graph keeps going. For the y, you see they start here, and then they keep going up. Okay, we look at another example. This is a rational function, and we have y is equals to minus 3 over x plus 2. So for the rational functions, like this one, I just need to make sure that the denominator cannot be 0. So what would make the denominator 0? So that means x plus 2, and focus on the denominator, cannot equal 0. So that means x, I subtract 2 from both sides, cannot equal -2. Why? So if I plug in -2, I'm dividing by 0, which is impossible. So that means the domain is every number except -2. So that means starting from negative infinity, it can be any number. But when I get to 2, -2, it cannot be -2. There will be a break in the graph. and then it's going to continue after negative 2 all the way to positive infinity. And note that in between there is going to be a break, so I'm going to use U for union. So this is the answer for so this is the domain. So this is going to be the domain. Graphically, if you look at the graph here, this is x is equals to negative 2, and you see there is an asymptote. There is a point of discontinuity on this graph. Remember, it keeps going in that direction, but you can see there is a discontinuity. So you can see it's everything except that, the negative 2. And you see negative 2 is not included. And let's talk about the range here. For the range, so we look at the graph. For the range, it's easier to look at the graph. So you look at starting all the way down. So it starts from negative infinity, and then all the way to 0, and then after 0, so I'm going to use union, it keeps going up, so from 0 to positive infinity. So that will be the range. Okay, so the next one, so here we have an example, and this one has a numerator and denominator, and we have to be careful about this one. So let me start with the numerator. So I start with the numerator, and what do I see in the numerator? I see a radical. So I know in the radical I cannot have a negative number. So this is the numerator. So I know that x minus 3 has to be greater or equal to 0. So that means x is greater or equal to 3. I'm not going to write anything about that yet. I'm going to look at the denominator. So I look at the denominator. And what does the denominator say? X plus 2. And I know for the denominator, it cannot equal 0. So I'm going to write not equal to 0. What does that mean? It means x cannot be equal to negative 2. So I have two conditions here. So this one says x cannot be negative 2. But I want you to look at this first one here. See, this one here overrides the second one, because it just says x has to be greater than 3, and I know it cannot. So that's the first condition. It has to be met, and this has to be met too. But see, the first one overrides the second one because it takes care of the second one. So now I can write the domain. Okay, I can write the domain, and the domain is going to be, can write the domain, and the domain is going to be x is greater than 3, and I'm going to write that using the interval notation. So I'm going to write from 3 is included, to infinity, from 3 to infinity. So that's the domain. What about the range? For the range, I can look at the graph. See, this keeps going up. So that means the range is from 0 to infinity. 0 is included to infinity. So that's how the range is going to be. Okay, now let's look at another example here. So here I'm given, this is the function given, and it's equal to square root of x plus 3. So I just have to worry about the denominator because I know it cannot be negative. So I'm going to write x plus 3 has to be greater or equal to 0. Okay, it has to be greater or equal to 0. So what does that mean? It means x has to be, so x has to be greater or equal to x has to be greater or equal to -3. But then there is another condition. See, the numerator cannot be 0 because I'll be dividing by 0. So here I have two things to consider. So I also have to say that x plus 3 cannot equal to 0. That means x cannot be -3. So why is this important? So here I have two conditions. Although the first condition here says that x cannot be, although the first condition here says that x cannot be, has to be greater or equal to -3, the next condition here says it cannot be -3. So that means x has to be greater than -3. So when you look at these two conditions, cannot be -3, here it says can be greater or equal to, so this is what we come up with. So now here we can write our domain. So the domain is going to be from -3, not included, to infinity. And you can see the graph right here. This is how the graph looks like. So it starts at -3 to infinity, and you can see every x value from -3, and the range, let's talk about the range. You can see the range cannot be, it cannot be 0, so it starts from 0 to infinity. So here, those are the answers. So that's how to find the domain and range of functions.